Welcome to another problem session. So this is a problem in electricity and magnetism. So this again come from JEE 2025 paper 2. Doesn't matter where it comes from. This is a very standard problem. And so what it's saying is you have a solid sphere conducting when there's some charge on it, so it resides on the surface. Okay, the charge will just reside on the surface because of it's a conducting, so it has to be only on the outer surface. Electric field inside is 0. So all these charges, this thing is rotating with some omega and charge on this is q, this radius. Mass this thing is m. So such a thing will have magnetic dipole moment as and maybe you memorize the formula. I really don't remember the formula. I'll teach you how to find the formula. Even in the exam settings, very fast. Maybe not 3 minutes fast, but within 5 minutes you can be done. Okay? So, all right. And then has angular momentum L, and it's saying that if I take a ratio of this mu over L, then I'll find some number here, alpha. That's the one we have to find out. Q over 2m. I would write like that. So L is not hard because about this is the axis of rotation. So L will simply be moment density of omega, and is 2/5 mr square for the I and omega. So this is, you should do it almost immediately. So this is my question 1. The question is how to get mu, right? There's only thing over here is you need to remember moment inertia, and I don't think in the time that you have in the test you're going to be able to also derive this formula. This formula can also be derived, but I wouldn't recommend it. Okay, so what we're going to do here to get mu is look at this sphere again, and going to this is the axis. So this is the center, and look at some point, that angle theta from it, and look at a bunch of charges on the surface, like a tiny belt. So this the belt width will be just r d theta. That's the width of the belt. So this belt goes all the way around, okay, and this all the charges are kind of going around. So let's call this amount of charge in this belt, I'm going to call this dq at angle theta. So we need to figure out surface area of that. Of course, it's going to be 2 pi. So this belt will be like, so if we know the radius of this thing, radius of, let's call it rho for that, is going to be, if this is r, then there should be r, and this is theta, r sine theta. So this will be 2 pi, and this side is r d theta. So the area of this belt, it will be product with these two guys, 2 pi r sine theta times r d theta, right? Okay, and surface area is got charge q. So how much is the surface area? Sigma in a coulomb per meter square unit, right? So that's going to be q over 4 pi r squared. So this is the entire surface area of that. So the amount of charge that's in this belt is dq theta sigma times dA, q over 4 pi r square 2 pi r square sine theta theta. Of course, all this cancel out, it gives you 2. So q over 2. Okay, so that's how much charge is there. And if you look at any point, let's look at a particular place here. All these charges will pass that point in one time period, right? So that's what the current is. Current is take any point and it's gonna, so if you have a wire, if I'm over here, think of this as a wire, at what rate the charges are flowing. So this charge goes and comes. So one time period, in time delta t, all these charges go all the way around. It's 2 pi over omega. So then the current, which I'm going to call di at theta, is dq at theta over the time it takes. So you have a omega q or 4 pi sine theta d theta. So this is the current. So I'm going to think of this as a ring of the current di theta. That's the ring. And so, of course, this is a ring like that. So we need to find this area, and we can assign, you probably know that if you have a ring of current I, and the area over which this ring is A, the magnetic dipole is current times A. Same situation here, so we can assign d mu at theta, the ring at theta, magnetic dipole moment will be pointed up from there, and I will have this magnitude up because use a right hand rule to get up. So that's the way you assign direction to dipole moment. So we have a di theta, and what's the area? Well, this one, just this radius is rho, so this is r sine theta, so it's going to be pi times r sine theta square. Now we can write this over here. So omega q over 4 pi sine theta, we can do d theta over here, and it's going to be pi r square sine square theta. This pi cancels that pi, so this is just simply omega q r square over 4 sine square theta sine theta d theta. I've written this like this because I can make this equal to minus d cosine theta, and we can say x equal to cosine theta. So this can be written as omega q r square over 4 1 minus x square minus dx, and theta goes from this theta goes from 0 all the way to pi. Theta goes from 0 to pi, so x will go from 1 to minus 1, and if you absorb this, then you can write the integral as minus 1 to 1. So to get a mu for this sphere, integrate d mu theta, which is 0 to pi, 1 to minus 1, this whole thing. Absorbing minus into the over there is going to be minus 1 to 1 omega q r square over 4, and the integration is 1 minus x square dx, which is pretty easy to do. One just gives me x minus x cubed over 3 minus 1 to 1 omega q r square over 4 1 minus 1 over 3 minus 1 minus 1 minus 1 minus 1 over 3. So basically double of that. So 2 times that guy, 2 times 2 over 3. So omega q r square over 4 third. So omega q r square over 3. All right, so we got a mu with omega q r square over 3 and L is 2/5 mr squared. Okay, hence mu over L and omega here. Five or six. I wonder what they gave us. 2m. They want this to be 2m, so this is 3. So alpha is 5/3, which is 1.66, which is 1.67. So that will be the answer. This will be 1.67. If I didn't have to explain that and kind of paused, just went straight to it, because this is a standard problem. So it's a standard problem. Textbook problem. So you have already had a lot of practice doing that. Now, I would say you should try doing some problems like this. Maybe you should do, okay, here's one. Try something like, I have a cylinder, length is L, and radius is R. Okay, so what's mu over L for this guy? If you think this is too trivial, try vertical ring. It's just a ring of radius R, and this charge Q. Charge is Q over here. So what's mu over L for this guy? So a whole bunch of these problems are standard. You'll see maybe on the advanced side of textbook, and you should try them out. Okay, so far so good. So I'll see you in the next problem. Bye.